Hi, everyone. Thanks so much for joining us tonight. I'm really excited I've never done this before. I've never been asked to introduce a paleontological movie. So my field of expertise is paleontology, Earth history, and I've never had the privilege of talking about it through this kind of lens with a film that's coming afterwards. So it was actually really enjoyable for me to prepare for this and think a little bit about Mary Anning and who she was and sort of where she sits in geological and sort of the field of geology history. So I'll be talking a little bit about that today. So this was a picture taken from my own trip to a Jurassic coast in England, but the northern one, not the southern one, when I was 20 weeks pregnant with my baby girl, who just turned 11. All right, who is Mary Anning? So she is the star of the film AMMONITE that we will see shortly. Her character is the star. So let's get into her history a little bit. She was a British fossil collector and a pioneering paleontologist. One of only 2 surviving children among her 10 siblings. So she grew up in Lyme Regis in the southern coast of England. And her family was not well-to-do. They lived on the coast, and they were avid fossil collectors. And so they would go out and collect fossils and polish them and get them ready for sale. And predominantly what they did is actually participate in the sale of fossils. What was interesting about sort of this historical moment, part of the popularity of the selling of the fossils was that because of external forces like Napoleon and other things, when people were vacationing, they weren't vacationing abroad. They were going to the British coast. So when people who were British wanted to go on vacation, they were flocking to the coastlines. These were becoming really popular vacation destinations, and then the fossils were built into this. And so she was selling these curiosities, and her father taught her how to collect and how to prepare them and get them ready for sale and to be sold. So she learned this was really primarily a sort of father-daughter thing, and his untimely young death led to her selling many of her fossil finds. All right, where did Mary live? So I wanted to talk a little bit about, I was brought here by Yasmin. I have to talk about rocks, a little bit of geology. Just suffer through my geological lesson if you don't mind. So those ammonites up on the right-hand side there are some of the most common fossils that emerged from these rocks. They were called snakestone because they look like they're a little wound up kind of coil that looked like a snake that was coiled on itself. They are actually a shell of the creature that would have lived inside that shell is a squid, something that's very similar to a modern-day squid, is what lived in those cephalopods, and they were actually predators of the ocean. This is her coastline, so these are the rocks that were so productive for her and for her kind of paleontological contributions. And normal people, not geologists, normal people walk along the coastline and say, look at this beautiful setting and these amazing rocks and, what a nice background. But we geologists are like, ooh, look at those rocks. Maybe there's an ocean, maybe there's something else, but look at those rocks. And so what we notice is that there are thick beds of rocks, and in between are what we would call the darker rocks are shales. You have the thicker beds that are the sandstones, and these are the rocks that produce so many of the fossils that Mary would find on the beach and up in the cliffs. And I'll walk through some of those exceptional finds in a moment. So what do geologists see when they see the rocks? So this is, if you look at the top diagram here, you can see Lyme Regis is off to the left. It's sort of out of the field of view. You have the cliffs in the background. And what's important to note, I guess, is the time periods is what I really wanted to highlight here. So the time period that she is interested, or the time period that produced these beautiful fossils that led to so many important evolutionary discoveries, are both the Jurassic and the Cretaceous. And so you can see, if you look at that hill there, some people, again, oh, look, hills with rocks. Look at the bottom diagram, that's what geologists see, right? We map them out. What makes up the hills? What is there? We have the Blue Lias Formation, which is Jurassic in age. Above it, we have more Jurassic layers of rocks, and then at the very top, you have a bit of missing time. We call that an unconformity, okay? So an unconformity is a period where there was no deposition, and then the deposition starts up again, and we move into the Cretaceous at the very top. Now, what's so interesting about this sort of stacking of rocks is that it is known as the first geological principle that you're taught in your introductory geology class, the law of superposition. It is that rocks at the bottom are the oldest, rocks at the top are youngest. It seems so straightforward, doesn't it? But like that's an actual law that had to be written down. When you get something where it's the opposite and the oldest are on top and the youngest are on the bottom, you know something funky has happened, like a mountain building event or a fold. But in general, the law of superposition posits that oldest at the bottom, youngest at the top, and it was a famous British geologist I'll talk about in a moment who actually made that claim. So these were her rocks. This was her time period. Jurassic, Cretaceous, you may have heard about movies like Jurassic Park. Maybe you've heard about those. This was a time period when dinosaurs were around. This was the Mesozoic. So this is the age of dinosaurs when these rocks were deposited. But she wasn't finding dinosaurs. She was finding things that were quite a bit different. Why was she finding things that weren't dinosaurs in these rocks? If you look up and see sort of the continent of North America, and if you look to the right of it and you see Europe that's written there, a lot of Europe was underwater. So England was underwater at this time period. It was not exposed land, it was underwater. So she wasn't getting dinosaurs in the rocks that were deposited near her. She was getting things that were living in the ocean. So she was mostly seeing marine creatures, again, because England was underwater during this time period. So this is what it looked like. Just a delightful place to have a tea party, so very British. One of the things that you notice, I kind of want to point out a couple of different things that are in this drawing. You have your swimming reptiles, not technically dinosaurs, but related. They are reptiles. They went back to the ocean and were swimming, many of them eating each other, as depicted here. Adjacent, you also have some of the snakestone ammonites. Again, these would be the swimming squid in the ocean. One of the other things that's kind of fascinating, and this goes to how you make a fossil record, you see the plants up on here, and it turns out that there are actually some plants that made it into her sediments that she studied. But the funny thing about fossils is that in order to make it into the fossil record, you have to be buried. So on an average day, when a leaf falls from a tree and lands on the ground, that has almost a 0 chance of making it into the fossil record. If, however, those leaves or those branches fall into the ocean or fall into a river, now the odds of it becoming a fossil have gone up. So only the things that were living right next to that ocean environment were the ones that made it in and then became part of the fossil record. But she also found, or people of that time looking at those rocks would also see logs and bits of trees that had been washed into the ocean. Okay, what were her specific contributions? So now that I've given you some geologic background as to why the fossils were there, what were her specific contributions? So her brother found the head of this creature that is pictured over there, and you'll notice that its name is Ichthyosaurus anningae, right? With Anning being a shout out to the finders of the fossil. He found the head and thought it was some sort of crocodile, not surprising, because when you look at it, it's sort of what it looks like. She was adamant that there was more, and she went back to the rocks and found the entire rest of the skeleton. So she is credited with the first ichthyosaur complete fossil. And one of the things that she had to teach herself, see, this is why I am an invertebrate paleontologist. Bones scare me, because look how complicated they are. I mean, when they're all nicely put together like this, no problem. But when you get bits and pieces, I'm at a loss. I'm at a complete loss. So she taught herself anatomy. Some of these unbelievable fossil finds enabled her to actually teach herself anatomy, how bones fit together, how they related to each other. So that was one of her kind of major things that she was able to do on her own. So this was one of the big finds. What is an ichthyosaur? One of my favorite of the fossils. Swimming reptiles and top predators of the Mesozoic era. So they have been, one of my favorite places to go visit is Ichthyosaur State Park in the lovely state of Nevada, where I got my favorite mug that says, "I dig ichthyosaurs," still have it. And that has a whole bedding plane of beautiful fossils where you can see these creatures, but they were really common. When dinosaurs were walking on land, they were swimming in the ocean. So they were one of the predators of the ocean. She is also credited with this other fossil, and here you can see she sketched it out. It wasn't as beautifully articulated as her ichthyosaur. So you have bits and pieces that are dislodged, right? Parts of the neck there that are dislodged, that she has them sketched off to the side. And she was the one who sort of recreated how this thing would have fit together. This is a plesiosaur. So also another large marine swimming kind of creature, would have been a predator much bigger than the ichthyosaur. So these are two of her major fossil finds, these huge fossils that she was able to reconstruct, sketch, document, and then had to be then folded into all of the evolutionary theory that would be written in the coming years. So what is the legacy of Mary Anning? So numerous exceptional fossil finds. And to be the kind of person that takes their time, and this is something I learned from my vertebrate paleontologist colleagues, you gotta go out and painstakingly brush away dirt and debris. You don't wanna break your fossil. And so I'm always dealing with kind of individuals like a snail shell. That's easy, you just get that. But when you have bones that are stacked together and articulated and fit, you're trying to keep that with as much integrity as you can. And so her patience, she was just an absolute exceptional excavator and curator of her fossils. In spite of never really receiving the credit she deserved, her fossils were key in the construction of evolutionary theory, and I'll talk about that in just a moment, how she sort of fits into the bigger paleontological picture. I love this quote because I thought it was one of those, like, it says really nice things, but with all these like kind of backhanded insults. But so a woman named Lady Harriet Sylvester had gone to visit her, and I just thought this quote was so perfect. It's something that could honestly be written about a woman paleontologist today, if I'm being honest. The extraordinary thing in this young woman is that she has made herself so thoroughly acquainted with the science that the moment she finds any bones, she knows to what tribe they belong. She fixes the bones on a frame with cement and then makes drawings and has them engraved. It is certainly a wonderful instance of divine favor that this poor ignorant girl should be so blessed. For by reading and application, she has arrived to that degree of knowledge as to be in the habit of writing and talking with professors and other clever men on the subject, and they all acknowledge that she understands more of the science than anyone else in this kingdom. Kind of, wink, wink. They acknowledge it, but she's not going to get allowed into the Geological Society. Let's not get ahead of ourselves here. And I wish I could say that this was just so of the moment in 1824 and nothing to do with 2024, but let me tell you. Still got some of that stuff that's pervasive in the scientific field. All right, so the heroic age of geology. So what is her kind of greater context? And this is one of the things that I just find most fascinating about this period of time. Between the years of 1790 and 1820-ish, there were much more extensive geological observations that were beginning to be made. So people were starting to recognize that you could learn from rocks, that there were things they could tell you, there was history embedded in them, and they were something that needed to be explained. So methods were developed for arranging rock formations, and the Geological Society of London, the very first geology society, was formed. So this was a moment when geology is really getting off the ground. George Cuvier was a French scientist who got famous for his thoughts on catastrophism. So what he recognized in the record is that there were intervals of massive floods, and that was part of the geologic record, and that turns out to be an important thing we think about even today. Charles Lyell was the one who wrote Principles of Geology, and among them is the law of superposition, this idea that oldest on the bottom, youngest on the top, and how you can start to think about what that means in terms of time. Charles Darwin and Charles Lyell were very good friends. One of my favorite stories to tell on my first day of my paleontology class is that the fossil record gave Darwin terrible indigestion. If not for the fossil record, he would have published on the origin of species about 10 years earlier. He already had all the ideas down. He had them all in his brain, he had written them down. He was scared to death of what they meant, and especially in a Christian society. What did it mean to be positing that evolution happened, that we evolved from apes, right? All these kinds of things, or from ape relatives. So he was really upset about the fossil record because it was incomplete. It didn't have perfect transitions of forms. And so on one hand, Mary Anning is helping him out with all these fantastic fossils. On the other hand, the indigestion is growing. What does it all mean? And how do you place it in context? So it was Charles Darwin and Charles Lyell's relationship, understanding both the geology and the biology at the same time, that really informed a lot of the work that was written. And I think that's sometimes lost when we talk about Darwin. We talk about him as an evolutionary biologist, but he was really good friends with geologists. So this is important to keep in mind. A lot to be learned. So we turn our attention to the film AMMONITE. So this has Mary Anning as a character in the movie. And when I watched it with much enthusiasm because A, I love Kate Winslet, and anything she'll do, I'll follow her to the gates of hell because she's wonderful. But also because I'm a paleontologist, so I was curious. What did it get right? So here are the things, I wanted to just take a moment and say, the things that I thought that it did really well, and things that were missed because of creative license, of course, but that I didn't know having watched this movie. So the marginalization of women as scientists in the 18th and 19th and 20th and 21st centuries is well captured in this movie. I think they did a really good job of demonstrating and showing what it felt like to be making contributions and yet not really invited to the dance. The conflict between stereotypical gender roles and field paleontology. And you'll see her in her ridiculous outfits out traipsing through the mud and the rocks, and now how lucky I am to be able to strap on boots and jeans and go do what I need to do. And so that kind of, and still to this day, the stereotypical, what is it to be a breastfeeding mother in the field? What is it to be a pregnant person in the field? What is it to be a woman and pee in the field? I mean, all these things are the kinds of things that we still deal with, stereotypical gender roles and what it is to be a field geologist. And then the omission of women's labor and contribution to major finds, especially in the second half of the movie. You start to see how she's made these significant contributions and is never recognized for them fully. Where the movie misses, I think, is in the partnership. So this is a love story of these two lead characters. Charlotte Murchison was actually an exceptional paleontologist in her own right. She contributed significantly to her husband's career based on all the writings and things that were documented. She was a collector and sketcher. She drew rocks and drew fossils, traveled around the world and documented all kinds of interesting things. That's not captured in this film. She's very much sort of a sadder character in relation to the main character that I think was a little bit of a miss, but I'll be curious to hear others' thoughts. There's also no real evidence for a romantic relationship between Mary and Charlotte, but wouldn't make for a very fun movie if that were true, so we can ignore that. And then it turns out that Charlotte also appears to have been happily married to her husband, which again doesn't make for a very exciting movie. So I understand why those were the misses, but that was something that I gathered having done research to come and talk to you tonight about some of these things. So those are my insights and introductions. I think I have time for just maybe 2 questions, if anybody has any quick geological questions for me, and otherwise we can start the film. Yes?
So when Charlotte Murchison was a paleontologist, was she that married, or did she become one by being trained?
Oh, that's a great question. Yeah, so the question was Charlotte Murchison initially a paleontologist? Or is it in her relationship? And I'll be honest, I don't know which came first. I know the two women became friends over the course of their career. My understanding was it was the sort of love of paleontology that brought them together, but I'm not quite sure exactly what that relationship is. Yes?
So did she, it appears like she didn't get a lot of credit, but did she get some money? Was she paid for this fossil?
Yeah, no, that's a great question. So the question was, she didn't get a lot of scientific credit. Was she paid? Yes, when she would sell her fossils, they did pay her, and that's how she was able to kind of make ends meet for her family and her mother, who had been left without a husband. Yep. So is that great? Great, thank you so much.